Hello. Hey everyone. My name is Ben Ogle, and today I'm going to talk to you about building dev tools on top of Atom. So for those of you who don't know what Atom is, it is an open source, it's a free open source text editor built at GitHub. There's one thing that I want to be clear about is that Atom is a desktop app. And so it has menus and it interacts with the file system and all of that. So it has it's a desktop app, but it is built on top of web technologies. So this is the Chrome Web Inspector open, and you can see that you can inspect anything in the interface just like you would a web page. So it is built as a desktop app. It's built on top of web technologies, and it's also using Node.js. And so with Node.js, we get a lot of power. Like we can interact with the file system, and we can like load native modules and things like that. So we get, with web technologies, by building on top of these two familiar technologies, we get hackability. And so what does hackability mean with Atom? Like what does it mean for Atom to be hackable? So everyone here knows JavaScript, HTML, and CSS. At least a little bit. And so all of you can extend Atom today. And so the second thing is that you can modify and style anything. And so if you didn't like the tree view, for example, on the left side of Atom, you can totally remove it if you want. Or you can fork the repository and edit it to your heart's content. You can publish your own tree view package that competes with our tree view package if you want. You can do anything. The third thing is that it's super easy to get started. And so I'll show you a little example here on how we've tried to make it really accessible. So let's say you're always converting these snake case variables to camel case. Like all the time, all day long, you're converting these snake case variables to camel case. But find and replace is too slow. So you want something a little bit faster, like maybe you want a key command, or you want some kind of command in the editor that you can run that just does this for you. So we have this concept of an init script in Atom that you can add quick hacks to. So it runs on initialization, and when it's loaded, you can add features to Atom. So we would just do atom.commands.add. We would say Atom text editor, which is just a selector that selects all of the text editors, and we give it a name of user:convert to camel case. And so this is what's going to show up in the interface. And then we just grab all the editors, grab all the selections, iterate over them, and do the replacement. And so if you know where everything is, this takes like 2 minutes to do, to add this feature of Atom, add this feature to Atom. And then it shows up in the interface just like this. And you can bind this to a key command if you'd like with your local key bindings file. So, but let's say everyone on your team had the same problem. Your init script isn't really going to cut it. You can't share your init script. So you can make it shareable by wrapping it up in a package. And it's really easy to make a package. You can just take the exact same code that you had in your init script, and you can wrap it in an activate method. And then you just have to have a package.json file that points at this file to say it's the main file. But after that, you can publish it to the package store, and everyone on your team or everyone in the world can download your snake case converter. So these are really simple examples, but I want to be clear that like the possibilities are endless. We get a lot from Node.js. So we can use native modules. You can write modules in C or C++, and then you can write node bindings on top of these modules, and you can use those inside of Atom. Or you can use existing native modules like node-git, which is just a wrapper on top of libgit2. So the second thing is you can spawn child processes. These can be long-running processes that do things, that do work, and that doesn't interrupt the main UI process. So the next thing is you can shell out. If you didn't want to use node-git, you can just shell out to Git. It's really easy. You can obviously access the file system, and you can use any of Node's built-in libraries like FS. You can also build crazy UIs, like stuff that I can't even think of, stuff that we on the core team would never build. So I'll give you one example of that. And this is a tabular data editor. This is built by somebody in the community, and it's something that we would never build on the core team. But you can open a CSV file, and instead of opening an editor, you open this interface, and you can add and remove columns, and you can edit the cells and that kind of thing. So there's a lot that you can do inside of Atom. But you can do anything you want, but we try to provide like helpers and primitives for common things. So you don't have to worry about how to render a selection. You just have to worry about your domain-specific problem. So I'm going to show you a couple of examples. I don't have tons of time, so I can't show you all of them, but this is decorations. So decorations allow you to highlight bits of text or highlight a line. You can add a CSS class to a single line or a CSS class to a single gutter line with the decorations. And so a lot of the core features are actually implemented using decorations, like selections are use decorations. Find and replace results use decorations. The Git interface in the gutter, it uses decorations. The next one is a custom gutter UI. You can add a strip to the gutter that has a click target and maybe adds a breakpoint for your debugger. And this is also, we have some core features that are implemented with this as well. The line numbers are actually just custom gutter UIs. It's the same code or same APIs that you can use in your package. And so the next thing is panels and pane items. These help us lay out the interface. So panels are around the edges of the interface, and the pane items are the things that you interact with in the interface, like editors, and like that crazy CSV editing interface. And so the last example is autocomplete. And with autocomplete, you can add any list of suggestions that you want. It could be famous tennis players from the 80s, like anything that you want. Or something a little more useful might be like you're typing a Python variable, and then you type dot, and you want a list of intelligent Python suggestions to be displayed. So you can do that with autocomplete. And I'm going to show you a little example on how you would do that. This is a complete autocomplete Python provider. So it's only 25 lines. And obviously the logic for actually doing like finding the suggestions is not in this 25 lines. It's in a project called Jedi. And Jedi is it's a Python project, and we just shell out to a Python script. We then leave that process open, and whenever we get a suggestion request, we write a line of JSON to standard in, and then Jedi returns us. It writes to standard out the list of suggestions. So then we parse this list of suggestions, and then we give them back to the autocomplete UI. So this is a complete example, and it's just glue code. The cool thing about Atom is that we can just write, there's so much tooling out there. All we have to do with Atom is write the glue code to connect it to your editor. And so this 25 lines produces this result. So anytime we would type something in a Python file, it calls our code, we call Jedi, and it displays in the interface like this. And so this brings me to Atom can be the glue between your tools. You can, like, let's say you had a build system, and let's say it was called Buck. You can take the output of Buck, you can shell out to Buck, capture the output, and put its output in a panel. You can parse that output and figure out what the progress is, display that progress in the status bar. So it can be the glue between your tools. It can also be the foundation for your custom tailored environment. So everyone here, we probably all work at different companies, and these different companies, we all have different development processes, and we have different development processes, use different languages, use like a different CI server, all of that. So there's this constellation of tools, and you can sort of round them up and have your editor be at the center. So there's a couple of examples here where Atom is the foundation. So there's a number of IDE-like packages that have been written on top of Atom for specific languages, like Go+, Atom TypeScript, IDE Haskell, OmniSharp Atom, and these provide things like autocomplete and linting and like click to definition, things like that. And then companies have been building their their development tools on top of Atom as well. So we have Particle.io, who makes a hardware development board. They wrote their development tooling on top of Atom. Jibo is a robot that wrote their development tooling on top of Atom. And then finally, you will be hearing about next is Facebook's Nuclide. So I'm going to turn it over to Ben so we can talk about Buck.
Thanks. All right, hi guys. I'm Ben Hamilton. I'm a coder at Facebook, and I'm going to tell you all about how we scaled past Xcode with Buck. So we have a kind of a core ethos at Facebook that any engineer should be free to go anywhere in the company and change any line of source code anytime. It sounds pretty crazy. A lot of us who have been at older companies know the way to do things is to ship binaries back and forth and have deadlines and QA teams. We try to basically break that down at Facebook and say anybody is free to hack on anything at any time. But once you allow people to do that, well, it's really frustrating. You have to sit there waiting for all those millions of lines of code to compile, either locally or distributed. It's a big waste of time for developers. You saw the earlier talk from Twitter. Just 5 minutes saved a day is going to be a percentage gained in productivity. And every time you want to go between teams, you're going to have to learn not just a new programming language, but a new way of developing. It's going to be a new IDE. It's going to be a new build system. You're going to have to learn how to debug and run tests. It's really frustrating. And at Facebook, one of our core values is we really want to encourage all of our engineers, newbies and old bees alike, to feel free to move around between teams. I worked on a team once for 3 years, and people were looking at me kind of funny, like, 3 years? What are you doing on that team? Go have a hack a month. Go explore the rest of the company. Learn what the other teams are like. So we want to provide everybody a foundation to be able to build, install, run tests for all of the applications at Facebook without having to relearn all of their tools. We started this by building Buck, which is inspired by a build system at Google. And we took our own twist on it and used it to build, install, and test Android applications. So today what we have is a system that now builds Android applications, React and React Native applications, and finally, iOS applications. So I'm really happy to announce to everybody today that we're officially announcing Buck support for iOS and macOS applications. So Buck can now natively, thank you very much. I'm so excited about this. So for the first time, Buck can now build, install, test, and even generate Xcode project files, which I'll talk about in a second, for your iOS and macOS applications. This is huge for us. I mean, even though it was originally written for Android, Buck builds a panoply of languages that we use in real life at Facebook. A lot of these are in our back-end infrastructure teams, because one thing that we really try to do at Facebook is we try not to be too prescriptive about what languages you are or are not allowed to use. And as a result, we have folks writing things in languages like D, OCaml, crazy things like Rust that are just becoming a new part of the development scene. And one really nice thing about working on the Buck code base for the past couple of years is it's ridiculously hackable. We have teams from all over Facebook and outside Facebook, since it is an open source project, contributing new fixes, support for new languages, all sorts of things we didn't even expect. And that's one of the beauties about the open source world. So now Buck is building React Native, Android, and OS X as well, and native C and C++. What's neat is you can hook any of these bits together. So you can have one stage of your build be a Python program that emits some C. That C can be compiled into a shader generator that generates GLSL that's fed into. And by the way, I'm not making this up. Some of these are actual parts of various parts of the build process that I've seen at Facebook. So the sky's really the limit with a flexible build system like Buck. So what is Buck? So Buck basically is a simple text file language. We call them Buck files. You stick them alongside your libraries, applications, and tests. They describe the code graph. So you describe a binary which might be composed of libraries, resources, scripts, and other things. That library might be packaged up in a binary. That binary might be tested by a test, and so on and so forth. All of these components of the graph are then parsed by the Buck software itself, which then understands how to not just build those things, but how to avoid rebuilding them if they haven't actually changed. We integrate with a really cool open source system called Watchman. If you haven't seen that, do keep an eye out for Watchman. It's super cool. The other beautiful thing about this is when you're generating those IDE projects, like who here has had to deal with a merge conflict in an Xcode or IntelliJ project file? Yeah, not the most fun thing in the world. So one of the beauties of Buck is by putting the knowledge of the code graph into this tooling, it generates all of those for you. It's beautiful. I mentioned really quickly that Buck's knowledge of the code graph allows you to compile just what's changed. So by integrating with Watchman, we get notified exactly when files change, and we can directly compile just those little bits of code and relink them transparently for you. What's really nice is our goal is to basically say any engineer in the company can come in, pull in this beautiful mono repo that you heard all about from Google and from Facebook, and in less than 30 seconds have the code built and installed in the simulator or on their device. And for apps as big as the Facebook for Android or Facebook for iOS app, that's no mean feat. We pulled it off by supporting very robust caches, which can either be local or distributed. I mentioned, our lovely friend, the IDE. You can't live with it, you can't live without it. But the beauty about Buck is, we abstract away the knowledge of the code graph. So, you don't even have to worry about IDEs being able to handle you manually dragging and dropping to move, 10,000 files from one project to another. It generates them all for you behind the scenes. But wait, there's a little bit more. I mentioned a little bit about testing. So my personal passion and the reason I started working on the Buck project is to really get people in that groove, in that flow of writing a couple lines of code, quickly running the tests for just what changed, seeing whether it passed or failed, and then going back and iterating that over and over and over again. I worked for a long time at a pretty big company where our QA cycle was measured on the order of 6 months. And now being able to run them in 6 seconds with Buck, I'm a lot happier as an engineer. And so what I wanted to give you was a quick example of what it's like to build and run tests for an iOS application using Buck. This application is available as open source along with the rest of Buck as an example. So you can see it from the buckbuild.com website. So this is a little application that we wrote to basically let the user know we're going to say hello to them. It has components in multiple languages. On the top, we have some library functionality written in C, and on the bottom, we have some stuff written in Objective-C. This could just as easily be C and Java, or Python and Objective-C++, or I don't know, D and OCaml. Like Buck is very, very agnostic when it comes to the components of the language. I have the logic on the top and the test on the bottom. Logic on the top says, I'm going to say hello from Buck. The test on the bottom says, I want to make sure that the logic says goodbye from Buck. Obviously, that's not going to work. So let's see what happens when we build and run the tests for this application. It's as simple as running a command line, a Buck test. This is going to build just the application and the tests needed, launch it in the iOS simulator, and it notes, hey, goodbye from Buck is not equal to hello from Buck. So I'm going to make sure I fix this. In this case, the test happened to be broken, so I'm going to change the test. I would rather you have tests that are good and fix the libraries, but this is just a demo, right? So I fix the bug. I run Buck test. It just builds the one single file. Takes 0.0 seconds to build and run it. My test passes in less than 100 milliseconds. And if I rerun it, Buck is smart. It knows by talking to Watchman that nothing has changed, so it doesn't even need to rebuild or rerun the tests that I've already just run. So it's pretty cool. So that's Buck natively building and running application-hosted tests in the iOS simulator. Again, this could be just as easily Android tests, C++ tests, Python tests, you name it. We have support for a whole bunch of them. And they all have the same front end, which integrates very nicely with the Nuclide IDE in the near future. So we talked a little bit about Atom from Ben at GitHub, and you're going to hear more about Nuclide in a moment. But Buck is the guts of the native language support in Nuclide. So Buck is how Nuclide shells out to Buck through Node.js and says, hey, how do I get the AST for this C file? How do I find the symbols available in this library? So that's how the type ahead and the syntax highlighting and all that stuff works for Nuclide's integration with C++, Objective-C, and so on. So Buck is available for you today. We have released an OS X brew package, brand new, hot off the presses for you all. So feel free to install it. It's brewtap facebook/fb and brewinstall-head Buck. It's fully documented. We've just released the documentation for iOS and Apple building today at buckbuild.com. And of course, it's all open source. We have tons of great contributors inside and outside Facebook who are making this better every day at github.com/facebook/Buck. So that's it for me. I'm going to be outside after the talk. Feel free to come up and ask questions about Buck, how we can help your teams build your software in a more scalable, open, and awesome way. So thanks so much. I'm going to give it over to James now for the next segment of the talk.
All right. Thank you, Ben. Thank you, Ben. I'm going to try and do a live demo. So let me just wake my computer back up. All right, it's awake. Good. So, yes, thank you very much, Ben. And Ben, my name's James, and I'm here from the Nuclide team at Facebook. Being an engineer at Facebook brings with a bunch of interesting challenges. One you've heard a lot about today is the speed at which we operate and the scale at which we operate. The amount of code that we're writing and the speed with which we're doing it for thousands and thousands of engineers. We also have this ambition to strive to make all of those engineers as generalized as possible and give them the opportunity to work on code throughout the code base. As Ben alluded to, we have engineers who can dip into any part of the code base, wherever it is in the company. And we want to be able to provide them with the tools that allow them to do that. And finally, this is something that we think is quite unique. We try to open source as much of our production grade stack as possible. In fact, we don't open source anything if it is not part of our production grade stack. But that itself brings with it some new challenges. So obviously one of the challenges is the size and the growth of the code base. How do we make sure our tools deal with this massive and fast-growing code base that we have? Secondly, how do we provide tools that deal with large numbers of languages and platforms? As you just saw, Buck is designed to work with a huge host of different languages. And finally, if we're open sourcing all this stuff, how do we make sure that we can also share the tooling that sits on top of it? So, obviously at the heart of most engineers' tool set is their IDE. And we look very hard at the off-the-shelf tools that people could use for building their code in the first place. And when we looked at IDEs out in the marketplace, we realized that they weren't going to fulfill our needs. Firstly, at Facebook, we need an IDE that can cope with C++, that can cope with Hack, which is our variant, our strongly typed version of PHP. We needed a tool that could work with JavaScript so that our React and our React Native developers could use, could use the same editor. We need to be able to support Objective-C for our iOS developers. And of course, we need to use Java, both for data infrastructure and for our Android apps. We would need such an editor also to be able to connect to our remote dev servers, especially the engineers that are working on www.facebook.com. They have to be able to connect to sandboxes that are in our data centers around the world, rather than local files. Finally, the size of that code base is very, very large. And so these tools had to be able to deal with those large files. And it turns out that many off-the-shelf solutions do not do that. And finally, as you may have heard in the past, we use Mercurial rather than Git, which means that a lot of tools that are making assumptions about Git being the source control back to the code just simply do not work in our environment. And finally, the tools that we build have to be able to work for mobile. More and more of our engineers every day are working on mobile, and we need to be able to support iOS, Android, and of course now React Native. There are no off-the-shelf tools in the world that do all these things, so we decided to build our own, and we call it Nuclide. Now, of course, we didn't actually build a new IDE from scratch. Thankfully, our friends at GitHub had already figured that there was a role for a project that would actually provide the glue that underpins many of the requirements that we had. And by working with the Buck team as well, we literally were able to, well, not literally, metaphorically able to stand on the shoulders of giants and be able to produce Nuclide from the pieces of the jigsaw that were all actually out there. We should actually literally try and stand on the shoulders of each other, but maybe after. All right, so one of the other things that we found is very, very important here at Facebook is to be able to effect large change with a very small team. So the Nuclide team is very, very small, and we are trying to move very, very fast. And we're building a product that is being used by a community of thousands of engineers at Facebook and many, many more thousands of engineers outside Facebook. And so this hackability that Ben alluded to earlier is really, really important for us. And in fact, had we not chosen a platform that was hackable by our colleagues at Facebook, this project would probably not be successful. It is an assumption, I think, that anything you build at Facebook has to be something that can be edited by anybody else. And so we've got this kind of virtual feedback loop going really well now. And many of the features that we have going into Nuclide are not being built by the core team itself, but are being built by Facebook engineers throughout the rest of the company, which is absolutely awesome. It's becoming a platform in its own right. We have a poster on the wall that says, Nothing at Facebook is someone else's problem, and this holds true for IDEs as well. Ultimately, like I said, we're trying to create a platform so that if there's something wrong with it or something that can be enhanced, something that an individual product team requires, they can build it. It just takes a little bit of JavaScript, right? Okay, so this is roughly what Nuclide is. It is a default install of Atom. We now have Atom installed onto every engineer's laptops as part of the Facebook standard build, so it's sitting there on their desktop when they first join Facebook. And there is basically one single package. Ben talked about packages. There's one single package called the Nuclide installer that you add to that Atom install, and it will then in turn go off and install a host of individual packages for each and every one of the languages that we need, each and every one of the features that we need to support. Let's take a look at some of the things that we have added. So this is a decked out version of Nuclide. As you can see, well, hopefully you can see, this is connected to a remote sandbox machine. My dev server happens to be in Oregon, I think, but Nuclide is treating it just as Atom would have treated a local file system, so I'm able to navigate the www code base. This file is actually prologued with $HH, which is our hack dialog. It's a version of PHP that has strong typing. As you can see, we have type annotations in the code there. We have a built-in linter that knows exactly how to check those type annotations to make sure that you are doing the right thing, which I am not here. In fact, I'm returning what looks like an int from a function that is supposed to return a string. PHP generally doesn't care about that sort of thing, but hack does, which saves us a whole class of different bugs. We also use the hack backing language service to be able to provide type-sensitive autocomplete. And as you can imagine, when you're a Facebook engineer hacking on something really quickly, being able to have all these autocomplete sequences for what is essentially a massive code base is a huge, huge improvement to productivity. Finally, as you might see just down the bottom, we have a little source control integration that shows you how many lines or different files you've edited. But of course, this is not Git. This is actually Mercurial, because all of our code is now in one single Mercurial repo. The same is true, obviously, of client-side development and JavaScript. In this case, we use Flow, which is our type version of JavaScript, just like hack is our type version of PHP. And you can see, again, we have an annotation at the top to say that that's what it is. And then we have, again, hints or lint errors when you've got it wrong, as well as hovering tooltips so you can explore the types and the structures of the various things in your code. And one thing that's kind of cool right down the bottom, I'm sure you can't really see it, but one of the packages that we've added for Facebook employees only is a little analytics tool that basically keeps track of things like how long each key press is taking, how large the heap is in Node, in Nuclide, how much memory it's using, what the CPU is, and what features people are using, and sends it all back to a central server. So we can actually keep track of what our engineers are doing, which features they're using, which ones they're finding value from, and what perhaps are causing performance issues, because obviously we want to make sure this is as snappier an experience as possible. And we can actually get to graphs like this. So this is our Nuclide consumer base over the last few months. As you can see, when we added a couple of key features, there was an inflection in the number of people using it. We are tracking Nuclide usage per day, per week, per month, just like our product teams might track features on Facebook itself. We're looking at individual features. We can see which ones are going well, and then they drop off when people find they're not working as they expected, and we can make some tweaks and grow those feature usages back up again. As you can see, we've been busy adding new features recently, so that population is rising. Again, just like a product team. And so this is a really interesting thing, I think, that at our scale, by the way, I did a black and a white version of that slide. I wasn't sure which one was going to come out better. I think white was better. At our scale, even infrastructure is a product. We can even A/B test our own dev tools to the population of developers at Facebook to make sure that we're doing the right things. And I think that's really fascinating because ultimately it means we're making a better product for both our colleagues and to the broader community as a whole. So, of course, it is all about standing on the shoulders of other giants. As you saw just earlier, Ben has announced that Buck is now supporting iOS, which is absolutely fantastic. What does that mean? It means that Nuclide supports iOS, and this is where my heart goes into my mouth and I try and do a live demo. So can you switch to the laptop, please? All right, so I have a slightly different theme going on here, but this is Nuclide, and I'm running the small Buck demo that Ben just showed earlier. This is standard Nuclide, and I have an iOS simulator over to the right-hand side. Look, I have no Xcode running. I only have the iOS simulator, no Xcode running. So we're going to run this little app, and I guess I can just run. I need to type in the target. This is the Buck demo app. Run that. Oh, it's not called demo app, it's called demo app. There we go. Got the wrong name. Run that. And now you can see the Buck output is coming up actually in the pane itself. As you can see in the simulator off to the right-hand side, it's now installed, and that should start up just shortly. You know, I didn't, oh no, we're waiting for another 14 seconds, 15 seconds. Maybe I'm going to have to kill the simulator. All right, well, whilst that's going, I'll show you the next thing. I guess I can get that right. I thought you said this was fast, Ben. You think my simulator's broken? All right, let's kill the simulator. Something had to go wrong, didn't it? Oh, now it failed to build. Of course it failed to build. Let's just try that again. There we go. Oh, now it's huge. I know what it was. It was my screen resolution that, well, it's vast. But anyway, there we go. If you can just imagine an iPhone. All the best laid plans. But again, just to stress, there's no Xcode involved. Right, so let's actually have a look at the code. So the one of the things we added to Atom, which when we have such a large code base as us, this is kind of a small app, but if you can imagine the Facebook app, and you can imagine the Facebook experience of large code bases, so we need to make it easier for people to find things. So we built a little Spotlight style file finder here. I'm just going to go straight into the app delegate, and let's have a look at the file. So here we go. This is Objective-C. We've got all the syntax highlighting. We are backing this with Clang, so everything you see in terms of coloring and autocomplete and so forth is correct, I guess. I actually don't know very much Objective-C, but let's see how far I can get. Look at that. So we get all the autocomplete that's coming out of Clang, just as you would do in Xcode. I'm not actually going to touch anything here. If you want to click to symbol to find out the definitions of things, you can, of course, hold down Command and click through. So this will take us through to the other parts of the file, the other parts of the project that we want to edit. And again, I can skip around the code base really, really easily. Now, I'm actually going to do a little bit of debugging here, one last trick, so to speak. I've put a little breakpoint here, as you can see, on the viewDidLoad function. And now we're going to launch the app one more time. Only this time, what's going to happen, and again, this is in Nuclide, in Atom, we now have a debug session, and we've got a breakpoint on that line of code. Now, what you might see here is that we're using the Chrome DevTools. Just going to have to get your head around this. We're using the Chrome DevTools on the right-hand side, which is a debug environment that's really familiar to JavaScript developers, but we're using it to inspect the iOS application that we're in. And so I have a full LLVM or LLDB little console down the bottom. I can do, let's have a look, label dot text. There we go. I can then evaluate that line of code. Hopefully it's been updated, and I can probably even set it to be hello at scale. This is about as much Objective-C as I know. There we go. And continue it to run. Switch back to there, and now it says hello at scale. Woohoo! All right. Switch back. Switch back, please. Switch back. I'm done. The demo's finished. Okay. So that was it. Very, very simple. The good news is that everything you've just seen, Atom, Nuclide, the iOS integration, Buck, and its iOS integration are all now open source, and they're all sitting on GitHub. So you can actually do exactly what I just did. These are all checked out directly from GitHub. There's nothing magical here that isn't available for everybody to see. So please go download Buck, go download Atom, go download Nuclide. You don't even need to run Xcode, and yet you can start building your apps. And as you can imagine, we're going to be continuing to develop this, particularly around React Native, and integrating that debugger experience into the whole set of tools that we have there. So it's all very exciting. So I just wanted to finish with there's the URL, github.com/facebook.nuclide. So I just wanted to finish with one final thought, which is that a lot of the things that you've seen just now, and a lot of the things that you've seen from Facebook throughout the day, are part of our entire production grade stack. Some of our best engineers work on developer infrastructure and on product infrastructure. And what you're seeing are not just funny little projects that we work on in our spare time. These are the real things that we use every day. And so we're committed to working on them, and we're committed to making them better and to sharing them with you as the community. Buck and Nuclide are just literally the two newest additions to that family. We hope, we are able to stand on the shoulders of others, and we hope that we are able to create shoulders from which others can stand on, upon which others can stand on. So, again, metaphorically rather than literally, and I hope that's given you an insight into what we're doing in developer infrastructure and with Buck and Nuclide, and I look forward to seeing you all out there on GitHub. Thank you very much for your time today.